In this chapter we're gonna talk about growth solver. So for the second setup we are going to create a growing solver. But before that I would like to show you two different examples. So let's copy paste it like this. And first of all the neighbor functions. So it's just a review actually. So let's see the viewport like this, and this is just a basic grid with an add to delay the primitive and the connect adjacent pieces to create lines. And here is the neighbor functions. So if I go there, I can see the point 3 there, and the first function is going to return the neighbor point number. So if I go to the geometry spreadsheet, I can see for the point 3 here I have the neighbor 4. And if I want the second neighbor, I just need to go there and set 1. But there is no second neighbor because it's just connected to 1 point and it returns -1 then. For the second function, the neighbor count, it returns the number of neighbor of the point. So for the point 3, there is just 1 neighbor and it's the point 4. But for the point 4, there is 4 neighbor. Okay. And the last function, the neighbors function, returns an array with the list of the neighbor of the points. So for the point 3, 1, 0, and 2, I have just the neighbor 4. But for the point 4, I have a list of those points 0, 1, 2, 3. So that's it. And just a quick review about neighbors function. And let's go to the second example. So here I have a grid, in simple grid. Let's take off the point number. And this is not what I should have. Okay, this is better. And I just merge everything with a transform. Okay. So I just set a color of 0, it should not be like this, this is better, okay, and the color over the point 0. So as you can see there on the corner it's red. And I'm going to apply two different solver. I mean there are a lot of different ways to propagate an attribute, but most of the time I'm using those two. So the first one is the one we used on the disintegration effect 1, and this is with the PC open. So if we go back there and I play it, this is what we have. And it's not going, because it's based on the radius, it's not going to stop if it's not connected. And the solver by neighbors, if we play it, it's going to stop by the connectivity. And this is the one we want to use. So let's do it. So let's create a sphere up with a color like this, with another color like this. Okay, I want to use polygons, not the primitive one. So there, and increase the frequency. Set the color to 1 for all the points, not 1 actually, 0. And the 1 for the point 0. So the point. Okay. Now I would like to check inside an attribute wrangle the neighbors. So let's create an attribute wrangle and say I at let's call it my neighbors equal neighbors, not you, neighbors function with 0 and at ptname. Okay, but it will return an array, so I need to export it, and if I want to store it I need to use the bracket there. So let's see what is the result, and as we can see there, we do have a list with all the neighbors. So this is what I wanted, but I don't need to export it and store the attribute. I'm just going to use it as a variable. So int, and I don't want the at anymore, and I need the bracket there. So now I would like to iterate over each point, and if the neighbor color is 1, then set the point color to 1. So I will use a for each for that, for each. This, let's create the int my neighbor like this, semicolon, and use my previous variable, so my neighbors like this. So now we need a curly bracket like this, and I want to get the color, let's call it my color of the neighbor, so point like this, 0 at cd, and my neighbor there. So Control C and paste it. Okay. Actually, let's call it my neighbor color. It will be even a bit longer, but like this. Okay. So now I want the maximum between my color and my neighbor color. So at cd equal max between @cd and we just copy paste it like this. Okay. So as you can see there, now those points are white. And if I take it off, you can see all the neighbors connected to this one are white now. So this is what I want, and I just need to plug that inside a solver to animate it. So let's call it set my neighbor color, perfect. And I'm going to create a solver like this, up, Control X, and copy paste there, like this, and go there, and that's it. So let's check it with the animation. So this is what we want. So let's make it a bit more organized. And now we can go to the third setup.